All right, question number 3 from 2024. These were the questions used last year. You're given the depth of seawater and you're given this differential equation. And it's measured in feet and hours. And it's known that h at 0 equals 4. So you're given a DiffEq. Step 1 is, can you draw on a slope field? So I already did it. If you start at 0, 4 and you follow the path of the slopes, you can see what the picture looks like. In part B, that's it for part A. Part B, it says it's known that h at t is always greater than 1. So the y-coordinate from 1 to 5 is always greater than 1. Determine whether there's a critical point that corresponds to a relative minimum, maximum, or neither, and then justify your answer. So for there to be a critical point, the derivative needs to be undefined or equal to 0. So I'm going to write down the derivative here. So we're at 2024, 3, we already did A, so this is B. I'm going to write down the differential equation and go, okay, what would make this 0? So that's the first thing we're looking at. So for a critical value, what makes it equal to 0? So either h equals 1, because if h equals 1, 1 take away 1 is 0. That makes everything 0. But that can't be the answer, because it says that for all values, it's bigger than 1. So that's not it. The other one that would make it 0 is if cosine is equal to 0. So I need to know my unit circle and know at what angle is cosine equal to 0. And that's the x-coordinate. That's up here. So for this x-coordinate up here, that answer is pi over 2. So if I look at this, what value for t would make it pi over 2 for cosine, so it equals 0, and that answer is pi. Now if you look really carefully on the graph, it almost looks like the answer is 3, that these are horizontal lines. But if you look really carefully, these lines are not horizontal. They're slanted, just ever so less slightly. The actual point where it turns is at pi. So actually at 3.14 is where the real turning point is. So the first question is, at what t value is there a critical value? And that's when t equals pi. The second part is, does that create a maximum or minimum? So you can look off the graph and see it's a maximum. And so if I look from 0 to 5, we have a critical value at pi. You can see that the derivative is increasing, then it's increasing and then decreasing, or the derivative is positive and then negative. So since at t equals pi, the derivative changes from positive to negative. Is a relative maximum. And you can also see it's a maximum by the actual drawing that it's a maximum value. And that's the actual curve of h at t. Not a derivative graph, but the actual graph of the function. That's what it looks like. All right, part C. This is the big question that has all the points. So part C is, can you solve the DiffEq? So we're going to write a differential equation. And then we're going to separate the variables and solve it. So first, I'm going to separate by dividing by h minus 1. Only that. I'm not going to divide by a half. I also notice that if you integrate the hook for t over 2 as a half, it goes together. It's easier to keep 1/2 on the right. I'll only divide by h minus 1. I'm also going to multiply by dt. So this is what it will look like when I separate the variables. There's step 1. So I multiplied by dt, I divided by h minus 1. We're good to go. We're going to integrate this next. The left side is a logarithm. If you take the derivative of the denominator, it matches the top. It doesn't need a hook. Make sure you remember the absolute value bars. On the right, when I integrate this, the hook here, the derivative of 1/2 t is 1/2. That's actually the correct hook. That's another good reason to keep 1/2 on the right side. so I don't need to make any adjustment. What's the rule for cosine when you integrate? And the answer is just sine, not negative sign, and then copy, and then plus c. At this step, we're going to plug in the point, which they said is 0, 4. So that means the h is going to be 4, and t is going to be 0, and then I'm going to solve it. So 4 take away 1 is 3. The value of sine at 0, so again, if you need to know your unit circle, at 0, the y-coordinate at 0 is 0. So that just leaves me with c equaling that. Then I go back to this equation. H minus 1 sine t divided by 2. Now I know what c is, which is ln 3. And then I need to solve for h. So to solve a logarithm, we're going to write it as an exponential. So that's e to the exponent sine t divided by 2 plus ln 3. To remove the bars, recognize the y-coordinate here. That you know, and it says here it's always greater than 1. It's a positive value. So it's going to be a positive value in front. And then the last step is we're going to add 1. And there's our answer. And that's it. All right, Mr. G Math over and out. That was question number 3.